Previously, in this epic journey through time, we went back 13.8 billion years ago to the Big Bang, where time and space exploded into existence. We witnessed the birth of light, the first stars, and our very own Milky Way galaxy, an ancient dance of matter, energy, and gravity, and followed the formation of our solar system 4.6 billion years ago. We dove into the dramatic tale of Theia, a Mars-sized planet that collided with the young Earth, creating the moon and shaping the destiny of our planet. Now the Earth is no longer just a lifeless rock. The seeds of life are about to be planted. It's now 4 billion years ago. Earth is young, violent, and seemingly uninhabitable. Molten rock flows across the surface. Volcanoes spew toxic gases into a dense, suffocating atmosphere. There is no oxygen, no land life, no blue skies. Lightning crackles through stormy clouds. Asteroids still occasionally pummel the surface. Yet water exists. Oceans have formed. And within these chaotic waters, something miraculous is about to happen. Let's take a moment to appreciate that even on a planet where no human could survive, nature was already experimenting. The scientists believe life began in what's called a primordial soup. Imagine the oceans filled with organic molecules, amino acids, carbon compounds, nitrogen ingredients scattered by volcanic activity, lightning strikes, and possibly even meteorites. Some theories suggest deep under the sea, near hydrothermal vents, life's first sparks were ignited. These vents, found in the darkest parts of the ocean, spew superheated, mineral-rich water. They created the perfect chemistry lab. Here in the darkness, protected from UV radiation, the first cells may have formed simple, single-cell organisms. These were the prokaryotes, ancestors to all life. They didn't breathe oxygen because there was none. Instead, they thrived in an anaerobic world, using sulfur and methane. Fun fact is these ancient microbes are still with us today. We call them extremophiles, organisms that live in the harshest places on Earth. But how did those simple molecules become something more? Something that could replicate, evolve, survive? Enter the RNA world hypothesis. RNA is like DNA's older sibling. It can store genetic information and act as a catalyst for chemical reactions. Scientists believe that RNA may have been the first molecule capable of self-replication. Imagine a tiny strand of RNA in a warm ocean pool, accidentally copying itself. Over millions of years, copying errors created variation. Some strands were better at surviving than others. Evolution had begun. Life had a spark. Now it had a way to grow. Around 3.8 billion years ago, Earth's surface began to stabilize. Crust cooled, oceans deepened, life spread. The first microbial mats, known as stromatolites, began forming in shallow coastal waters. These layered biostructures were built by cyanobacteria microbes that could do something revolutionary: photosynthesis. Photosynthesis changed everything. These bacteria began using sunlight to convert water and carbon dioxide into energy, releasing oxygen as a byproduct. At first, that oxygen had nowhere to go. It reacted with iron in the oceans, turning them red with rust. This created the banded iron formations we still find in rocks today, but eventually, the oxygen escaped into the air. Earth's atmosphere started to change. Oxygen catastrophe. The great dying that created life. About 2.5 billion years ago, the oxygen released by cyanobacteria built up to toxic levels for the existing anaerobic life. This event is called the Great Oxygenation Event, or oxygen catastrophe. Ironically, the oxygen that gave us breath nearly wiped out the early biosphere. But evolution adapted. Life forms that could handle oxygen thrived. Cells developed more efficient energy processing structures, mitochondria. This event set the stage for complex life. Daily life connection. Every time you breathe, you're using a process that dates back over 2 billion years. Roughly 2 billion years ago, something unprecedented happened. A cell swallowed another cell and didn't digest it. That inner cell became the mitochondrion, a powerhouse that allowed the host cell to generate more energy than ever before. This was the birth of eukaryotic cells, the building blocks of plants, animals, fungi, and us. These cells were bigger, more complex, and capable of forming multicellular organisms. This was a cosmic upgrade of life itself. Snowball Earth and survival. Twice, between 700 and 600 million years ago, Earth went through global glaciation events where ice may have covered almost the entire planet. Life teetered on the edge, but it endured, clinging to warm pockets near volcanoes and deep-sea vents. Some scientists believe that these harsh conditions pushed life to evolve faster, setting the stage for the next big leap. Suddenly, life exploded into diversity. The Cambrian explosion gave rise to nearly all modern animal phyla: sponges, worms, mollusks, arthropods. Creatures developed eyes, shells, skeletons, and movement. Predator and prey dynamics began. Ecosystems formed. It was as if Earth flipped a switch and life turned technicolor. But the question is, how do we know any of this happened billions of years ago? Fossils tell us what lived and when. Isotopes reveal environmental conditions. Genetics lets us trace lineages back through time. Radiometric dating shows the age of rocks and fossils. It's a combination of geology, biology, chemistry, and physics, a symphony of science. And the mind-blowing fact is your DNA still carries traces of ancient single-celled organisms. In a way, you are the result of 4 billion years of unbroken survival. So, life found its spark in boiling oceans, survived cosmic collisions, choked on its own breath, adapted, and began to evolve into complex beings. But we're not done yet. The stage is set. Coming up in episode 4. How did plants colonize land? When did the first fish crawl onto dry ground? And what was the greatest extinction event the world has ever known? Land will rise, life will walk, and the Earth will change forever. Stay tuned. Thanks for watching full video, and please subscribe and hit that bell icon to get updated on next episodes.